this video, we are going to learn the hydrostatic force or the application of integration in Calculus 2. So hydrostatic force are the resultant force caused by the pressure loading of a liquid acting on submerged surfaces. The center of pressure is a point on the immersed surface at which the resultant hydrostatic pressure force acts. So, example of hydrostatic force. So we have find the hydrostatic force on the vertical plate submerged in water. So this is the water. Here in our illustration we have this is the water, the curve, and the vertical plate we have here this one. So in this situation, we use the meters. So in hydrostatic force, if we use the meters in our measurement, we use also the weight density. Our weight density always is 9,800 newtons per meters cube. So that is our weight density. The measurement that we use is meter. Also, we have the formula, which is force is equal to the integration from C to D, h times y times ly dy. So that is our integration or the formula of our hydrostatic force. So now we are going to find the hy and ly in order to calculate the force in the given problem. So our hy is always negative y here, always negative y, and also we have ly here. The value of our ly is 2, since the square is the same. We have the same measurement. We have 2 and 2 meters. So ly is equal to 2. So substitute its value. We have the force is equal to the weight density. In our formula we have, the formula of our hydrostatic force is we have F, or the force, is equal to weight density W integration from C to D h times y ly dy. So substitute its value. We have weight density, which is 9,800, because we use the measurement of or the meters. So we have 9,800, or the integration from -4 to -2. Why we have the -4 and -2? Because here in our illustration, as you notice guys, we have 2 meters here, 2 meters here, and 2 meters at what in a size of square. Point here and point here. So since it is 2 meter in negative y-axis, or the negative in a value of y-axis, which are the where the plate position. So since it is 2 meter, and from the water and this vertical plate is 2 meter also, the distance. We have 2 meter here, the distance of the water and the object. So 2 plus 2 is equal to 4. That is why we have 4 here, but it is negative, because in a y-axis we have this is negative value of y, and this is positive value of y. So that is why we use the sign positive, negative, sorry. So we have negative 4, and also negative 2 because at this point here, from the water into the object is 2 meters, so that is why we use 2. So again, that is negative 2, it because the value of y is negative. As you notice that this graph, this is a form of y-axis and the x-axis. We are done in substitute this value of weight density, value of h times y and ly. So now we have now the 9,800 integration of negative 4 from negative 4 to negative 2 negative y times 2 dy. So we simplify this one, we have 9,800 integration of negative 4 to negative 2 negative 2y dy. So negative 2y, we have negative y squared from negative 4 to negative 2. So to substitute this value, or the value of its here guys, 9,800 times negative 2 times negative 2 squared is equal to 4, and negative 4 squared is equal to 16. So that is 4 minus 16 is equal to negative 9,800 times negative 12, or the result is 117,600 newtons. In this problem, vertical plate submerged in water is equal to 117,600 newtons.